This is a work in progress. I try to fit science into the egg. 7 serpent spirals of blood vein fields expel from source. The escape event horizon, where we are, leads to 7 outer veins or rungs of expansion, the 4th being the largest and furthest from source. Then begins the contraction, the pull, contracting yet speeding up at the return event horizon to the speed of light into the core of the final 7 rungs. And these are my notes from trying to research things over my head. Accelerating expansion of the universe. Observations show that the expansion of the universe is accelerating, such that the velocity at which a distant galaxy recedes from the observer is continually increasing with time. From space.com, we were able to follow an Earth-sized clump of matter for about a day as it was pulled towards the black hole, accelerating to 1/3 of the velocity of light before being swallowed up by the hole. The velocity you need to escape the black hole pull is equal to the velocity of light. How does distance affect magnetic force? Let's come to the relation between magnetic field and distance. Basically, there comes a very important law which is known as inverse square law. Magnetic monopoles and dipoles show the same relationship between the magnetic field and distance. That is, magnetic field strength increases when the distance between the field and source decreases. In simple words, it can be said that if 2 same poles of 2 magnets are brought closer to each other, the force of repulsion between them will become more and more stronger. Similarly, force of attraction between the 2 poles will become stronger when 2 opposite poles of 2 magnets are brought closer to each other.
Our universe, the vastness and beauty, with endless expanse and wonders to behold, opens our mind to possibilities and the wonderment of it all. Slowly, cosmologists try to unravel the mysteries of the universe, how it all began, the black hole mysteries, and more questions arise each day as new findings are revealed. Then, there are those earnest seekers of the truth, who have in some way elevated their consciousness to have a direct experience with the universe. Itzhak Bentov was one of these individuals, lovingly called Ben by those who knew him well. What would it be like if you had full access to the universe, unfolding its secrets for you as fast as you could postulate questions and ideas? Journey now with us from the creation of this universe to beyond the Great Wall, as seen by a true mystic and seeker of truth. After a long time of contemplation in the great void, the creator of this universe moved and became manifest in order to evolve. Then, outlining a part of the void by enveloping it in an ovoid shape of golden light. This creator is not male or female, but both as one. And in order to activate the process of evolution, they have to separate and move to opposite ends of the cosmic egg. Once separated, they want to come together again. The whole cosmic egg shakes with the tension of this separation. Then, the positive extends with a thunderous sound, and as the creator moves to the center of the egg, the protospace begins to flow along the sides of the egg, outlining the area where space-time and matter will be. Matter fills the matrix, and evolution begins. Looking closer at the universal center, we find a quantum singularity, a white hole and a black hole side by side, one recycling all matter and universe, and the other the source of all light and matter.
My name is Paul Steinhardt. I'm at Princeton University. The inflation model is an attempt to solve a fundamental problem with the original Big Bang picture. The Big Bang is not something we really deeply understand. We have no theory of the Big Bang, but our notion is that some random, highly turbulent quantum beginning from nothing to something. And so it would leave a universe which is very random and distorted. So yet we don't observe that's the way the universe looks today. So we need some idea to fix that. So inflation was invented as a fix, as a brief period of extremely rapid expansion that would occur after the bang, whose purpose would be to smooth out those initial highly uneven distribution of matter and radiation. This inflation that occurred in the very early universe that not only smoothed the universe, but also produced a little, what first thought was a small amount of desmoothing that would produce hot spots and cold spots in the early universe. So you should also expect to see, along with this, gravitational waves that accompany all those fluctuations that you produced in the distribution of matter and energy. But we don't see those. The Big Bang is this period in which quantum physics dominates over classical. So you might wonder, is it possible to construct a theory of the universe in which you don't have a bang, and in which you never have a period in which quantum physics dominates over the classical? That universe is, in terms of its average properties, always following deterministic equations, classical equations of motion. And that's the idea that we're pursuing, that instead of a bang, there was a bounce, that the universe underwent a very long period of contraction. It's during this period of contraction that you can smooth and flatten the universe. And quantum fluctuations in this case will produce hot spots and cold spots, but not ones that produce a quantum runaway effect. And one of the things I find appealing about the bounce idea is that there it has a natural role. If you imagine that the universe didn't just bounce once, but bounced at regular intervals, why would there be one bounce? Why wouldn't it repeat? All the lumpiness and randomness you observe in the universe today somehow has to be smoothed out before you get to your next bounce, in preparation for the next bounce. Dark energy is a natural mechanism for producing that. It's driven by an energy which is very, very close to zero, just on the edge of going from positive to negative. The fact that it's slightly positive right now means that it is causing this accelerated expansion. But it's also easy to imagine that it's slowly decreasing in its concentration, and if it decreases and goes from slightly positive to slightly negative, that will automatically cause the expansion of the universe to go from accelerated expansion to decelerated expansion, and then to turn around and go to contraction.
About 13.8 billion years ago, all the matter and energy in the universe was compressed into a tiny point of infinite density and temperature called a singularity. Then, for some unknown reason, this singularity exploded and started to expand rapidly, creating space and time along the way. This expansion is still going on today, and it explains why the universe is so big and diverse. According to Einstein's theory of general relativity, time and space did not exist before the Big Bang. A black hole. A black hole is an object so massive and dense that nothing can escape its gravity, not even light. But what if there is something else inside a black hole? What if there is a whole new universe? This is the idea proposed by Nikodem Poplawski of the University of New Haven. He argues that our universe was born inside a black hole, and that each black hole may contain a new universe inside it. He calls this theory cosmological natural selection, because it implies that universes can reproduce and evolve through black holes. Hawking radiation is a phenomenon predicted by Stephen Hawking in 1974. He showed that due to quantum effects near the event horizon, black holes are not completely black. According to Poplawski, when a star collapses into a black hole, it creates a seed of a new universe inside it. This seed is very small and dense, but not infinite. It has a finite size and mass, determined by the mass of the original star. It also has a lot of spin, because some black holes spin very fast. This spin creates a huge amount of torsion, which prevents the seed from collapsing further. Instead, the seed bounces back and starts to expand rapidly, creating space and time along the way.